Right, hi. This is for those of you who I unfortunately could not visit due to the multitude of illnesses my children have given me recently. So this is the lesson on using raster function templates and other things like that. I'm recording this at night, so bear with me. All right, so to start this lesson, we're only going to use one raster layer, and you can actually find it in either ArcGIS Online or Living Atlas. It really doesn't matter, but you're going to search for land cover. And what I told the students is this top one is your oldest version. I believe it goes back to the 80s, but it is very low resolution. It is global. The next one down is also global, a little bit higher resolution, but from the 90s on. And then if you're looking for land cover of the United States, this is your best one right here. This is the highest resolution at 30 meters, and this is the one we're going to use. Now, this layer is a multi-dimensional raster, and I got ahead of myself, but I guess I'll just wait for that to load, hopefully. If you do click it more than once, you will add it more than once, and it will take twice as long to add. So patience is the key in this lesson. Multi-dimensional raster, we know that because it has animation at the bottom, a time slider. So the first thing is we're just going to go ahead and disable that time animation. It's now located over here above search rather than in the tools on the right side. And when you have a multi-dimensional raster like this, you're going to get these options on the side, including this fifth one down called Image Collection Explorer. So this will tell you that there are 18 images in this raster set, and you could wait for it to load. Oh, actually there's 32. 18 last time I checked, but 32 total. And it really depends on how far zoomed in you are. So if you are in past Hawaii and Alaska, that will change it to 18, which is the number I'm used to seeing. Okay, so to work with a multi-dimensional raster, you really want to use this filter button right here on the right. And you should be able to leave display extent. You might have to change it to all if it's not playing nice, but we're going to go ahead and change our attribute to start year. And then we want to start year of 2001. This set of rasters runs from 2001 to 2022. And so we're going to grab the first raster in the set and the last raster in the set. So we're going to grab 2001 by pressing apply. And I'll go ahead and zoom out just so you can see the possibilities. There are 4 total rasters. There's PR for Puerto Rico, HI for Hawaii, AK for Alaska, and CON US for contiguous United States. That's the one we want. If you want multiple of these, you can press select, but we only want the single one. So we're going to click this add image to map video or button. That's going to add it over here. Now, what I want you to notice is it does change which layer you are looking at in the Image Collection Explorer. So if you go to do the filter now, you don't have one. So start here. It's 2001. So if the kids say they're stuck, that's what happened. So go ahead and change it either up here in the title or over here in your layer list. And then you can immediately go to filters, change to 2022 and press apply. This can take a while, especially if you're running 30 of them at the same time. So again, patience is key. Now, note that even though this says start year 2022, it's actually called 2021 trailing, but this is the most recent image they have. So go ahead and press this add image to map again. At this point, I really suggest you close this, otherwise it's just going to keep loading, especially based on your display, and we don't really need that. Now, I have several tips for working with rasters. The first is to save locally, meaning right now all of these layers are being pulled from Esri servers. There are no local copies in your organization. So the way you save locally is to go to the right of the layer and go to Save As. And I just call it NLCD, which stands for National Land Cover Database 2022, which is the year, and then my initials. I'm not worried about tags and summary here. I'm going to do the same thing for 2001. So NLCD 2001 and my initials. You can really save your map at any point. I suggest getting at least these in here first before you try to save it. Otherwise, you're just going to keep doing the same thing over and over again. And if those layers don't load, there's really no point in saving. But when you are ready, we're going to call this land cover lesson and your initials. In terms of tags, my rules are, what are you studying? So we're studying land cover. I'm also going to add raster since we're doing specific raster analysis. Where are you studying? We're studying the USA. And when, so we have 2001 and we have 2022, or if you would like to put 2021, you can. And then for the summary, land cover lesson by JMU, educational use only. Okay, go ahead and save. Now back to saving locally. We saved these layers, but the layers we saved are not in the map. These are still the ones being pulled from Esri server. So we're going to go to add. And we're going to go ahead and add the two new layers. So 2001 and 2022. And as you can see, that's everybody's favorite phrase, as you can see. It's going to take a minute. So we're going to be patient and wait for it to load 2022. And the other thing we can do once it loads those is we can delete the originals. So we no longer need the full database. We no longer need start year 2001, and we no longer need start year 2022. At this point, we are going to go ahead and save again. We're not going to save as, just save. That way, at least if you have to start over, you have a map you can use. All right. So at this point, I like to show them something local. Let's just do Loudoun County. And I'm going to zoom in towards this Leesburg area. And I just like to turn on and off the 2022 layer and just kind of show them like how much it's changed over time. And then just talk about quickly what those changes are. At no point have we actually looked at a legend at this. I kind of asked the students what they think the colors are, and then remind them that we do have a handy dandy legend that we can take a look at. I also at this point pull up LCD legend and talk to them about the pixel values. So I click this first one and explain that even though the legend is showing these categories, it's really those pixel values that are saved. So open water has a value of 11, developed land has a value in the 20s, forests in the 40s, et cetera, et cetera. And it's these pixel values that the computer reads and what we're going to actually use for our analysis, regardless of what these categories are. And that's really useful, especially when you're looking at a global layer, because this could be in a different language, but with those pixel values, you would still understand what it means. So our test area is going to be Lake Mead. So Lake MEAD, and then you are going to have to type in NV for Nevada, or you're going to end up in Pennsylvania. And once we go to Lake Mead, I have them just take a look at the 2001 lake versus the 2022 lake and just how much it has shrunk over the last 20 years. Talk to them about the city to the left being Las Vegas and how much that's grown. And then I give them tip number 2, which is to center your study area on your screen and add a bookmark. So we're going to do that. And we're going to have a Lake Mead bookmark. I've saved this a few times. And then we're just going to save again. I like to save as strategic points so that if a student has to redo this, which inevitably at least one will, we have those strategic points. And at this point, we're ready to do our analysis. So because we're working with a raster, we want to set up our environments. We're going to go to analysis settings. And the one we specifically want is processing extent. Third tip, when you're working with rasters, you always want a display extent. And now, once you set that display extent, you have to make sure that you know what is on your screen is what's going to run, which is why we save that bookmark. So, oops, I lost my area, or I zoomed in or zoomed out too much when I was exploring it. I can go back to my bookmark and recenter my screen. And that's a good habit to do before you run any analysis, just to make sure that you're running the exact same location each time. So what we want the program to do is tell us when a certain pixel was a value of 11 in 2001 and is no longer that value in 2022. So definitely up here, we have a bunch of the water disappearing. And you can do this for any of the land covers. The example's water just because there's only one pixel value, but if you wanted to look at development, you would just run the 20s. If you wanted to look at deforestation, you would run the 40s, et cetera, et cetera. Okay, so one thing about rasters to remind them is that rasters don't inherently have an attribute table. That's a vector layer. And so if you want an attribute table, you have to create one. And for that reason, we're not going to run a raster function, which is a singular analysis tool. We're actually going to run a raster function template. So we're going to click on raster function templates, and then we're going to click create new. At this point, I tell them to close everything on the screen, which just leads them to stay within this window for the most part. A lot of the buttons have similar names in the other windows, and I want to make sure that you stay within the template. Otherwise, it's not going to work. So we're within our raster function template. We'll go ahead and save again. And we'll start building. So to add raster functions, they're over here on the right. You're going to click add raster functions. And then the first one we want is compute change. To add it, you have to click the plus sign. You can't just click the button, which is weird, but is what it is. And I explained to them that this is a scratch coding environment. So we're building little building blocks of code. You can't actually see the code running here like you can in Pro because ArcGIS Online is a low code, no code environment. So but if they're really curious, they can run these tools in ArcGIS Pro and actually look at the code behind them. And then the second one we want is attribute. So we search ATT for attribute and we press the little plus sign. And that'll put it up here in the corner. And it does this in the same place for everybody's screen. So it's really easy to see. Then close your raster functions. And this is the hardest direction, believe it or not. You have to hover over compute change and see where the word alt is. And notice how here's a crosshair or the arrows, but then if I move just slightly to the right over the circle, I get the pointer. And I want the pointer. And I click and drag it up to attribute table and then let go. What that looks like if it isn't done correctly is, I don't know if I can delete this. I thought I could. Delete. There we go. So if you're on the crosshair, then you're just going to move this around by accident. So again, hover over the circle, click drag. So at this point, we're going to set up our parameters. They can move these buttons around the screen if they want, but we're actually going to auto layout layers so later, so it doesn't really matter where they are. But some people get really frustrated with them being this far apart, so they move them around. Double click compute change. It wants to know what your first raster is. That's the from raster. That's going to be 2001. And your to raster is going to be your later raster, which is 2022. In terms of compute change, difference is referring to a subtraction of the pixel value. So I kind of go back and say, well, if we want to see where the land went from barren land to open water, we don't want to subtract these because that's going to be 11 minus 31. That's going to be negative. We just want to know where it changes. So that is a categorical difference right here. And then it wants to know what class value are you looking for? We're looking for 11, which is open water. And to get it to commit, you either have to press add or you have to press enter. If it's still up here in the box, it's not actually committed. And then the two class values, you can choose to do this in parts if you want to do just two class values to start. If you want to do all five, I'm going to do all five for this just to keep this moving. So 31 is the first one, The second one is 95. The third one is 52. The fourth one is 71, and then 90. And they are barren land, wetlands, shrubs, grassland, and woody lands, respectively. And then you just leave everything else the same and click OK. Notice how that puts your two input rasters and it's super messy. So the auto layout button is right here. Zoom in, zoom out, auto layout. And I just press that and leave it like that. This point, we're going to set up our attribute table. So I double click there. Notice how you can't input a raster. It is taking the raster from the previous step, the compute change raster, and automatically filling this in. Then the other thing I make sure to tell them is do not change the value. Value is being pulled from the raster itself, and rasters always start with 0, not a value of 1. So leave the value of 0. And then the order matters. So the first class name we put in was 31, which is barren land. And I let them choose, or I have them choose white for this first one. I tell them we're going to use a dark gray base map. So white or lightish pink is fine. Then a value of 1 is going to be wetlands, and choose a color. Anything that's bright and is going to show up on dark gray base map is the goal. 2 is shrub. 3 is grassland. And then 4 is woody wetlands. And I tell them, I don't name them, I just tell you what they're called because the names get a little confusing, but there we go. Okay, so bright colors that are going to show up on black. They're in the same order that we put them in the compute change function, and we go 0 to 4, even though the IDs are 1 to 5. And if this is wrong, the tool will not run correctly, so make sure that's correct. At this point, the template is done. We can go ahead and press save as, and I call this lake change in my initials because we're specifically setting this up to look at where the lake or the open water pixel is changing. And then I don't worry about tags or summary for this. Okay. So at this point, we are ready to run our tool, and there's an open to run button just slightly to the left of save, so you can press that. And notice how it's called lake change, and then it shows your compute change function at the top. Everything's already filled in for you. If you scroll down, you get to your attribute table. Everything's already filled in for you. All they need to do is give it a name, like Mead, and their initials. And then sanity check the environment settings. Make sure your processing extent is the display extent. Go ahead and close this template and then just check your bookmark one more time. It's really important that this is centered, and go ahead and run. Now here's the most important thing. Don't leave this screen. This is going to take a minute to commit. And if you move away from it, the kids are going to think it didn't run, and then they're going to click it a bunch of times. And as soon as it submits, I'll be able to show you what happens when they do that. So we're just being patient. There it goes. You have to wait till it says like changes submitted, and you get this blue dot up here, because if you don't, it's just going to say, you know, run a tool to see the history. There's provisioning resources. It's going to be there for a while, and if they press that run button more than once and you get 2 of these provisioning resources at the same time, it will never end. You literally have to start your map over again, which isn't the end of the world because we've been saving it as we go, but you cannot your map will never stop running if you have 2 of these provisioning resources. If one's provisioning resources is 1 is running, that's fine because then you can actually close it. But if they are impatient and click that button more than once, then they are going to have to start over again. While it's running, I have them go to their layers and hide visibility on both of those, and then go ahead and change their base map to that nice dark gray canvas because it looks really neat when the layer pops up. If they saved before they ran the tool, this is actually pretty easy to fix. So I would tell them not to save after they press run until it's finished. Um, and I'll show you why. So I'm going to go ahead, and that's what the outcome looks like. We'll come back to that. I'm going to save as really quick, just put a 2 there, and show you what happens when you run this twice by accident. So if I go back to raster function templates and I run again, oops. Oh, I have to add a new letter to my name. So 2, and I run, and then I was impatient, and I go off my screen, and I go back and I run again. Give that a second. Should have 2 of those pop up. There's 1. And if I did it, yeah, there we go. This will never stop running. So if they get stuck like this, what you want to do is have them just go to their content and just open their map again. So it should still be in the same place. It should still have these layers. And the nice thing is you saved your templates, so it's really easy to find again. Just go to raster function templates, and it may show up here or it might not. You might just have to go to the folder, and then you can click on it and run it again, just open to run. But I'll actually go back to that previous map and show you that it is still running even though I closed it. So content. Nope, that's the wrong one. This one. And if I go to analysis and I go to history, oh, it's playing nice tonight. Sometimes it just stays forever running. So I guess we lucked out, but sometimes these provisioning resources will just stay forever. Okay, so here is our change. Here is our legend. We can see the different amounts, and I kind of asked them which one do they think is the most, and then, well, let's actually find out. So the last tool we're going to run is zonal statistics. So that's just a regular tool. And it's actually right here, zonal statistics table. Don't run zonal statistics, the one I actually said, because that is a raster. You just want this table. If it's running forever, they probably accidentally ran that. So with zonal statistics, input zone is how far do you want the statistics to run. So the distance is the change layer or the lake mean layer. Zone field is value, and then the input raster is what do you actually want it to run on. So you can have these two be the same, or they can be different if you have like a different boundary than your raster. Leave all of this the same. I just call this lake mean values. And then I'm going to go ahead and run that. And again, just be patient. Sometimes it takes a minute to commit, sometimes it doesn't. This is the table you get. Again, note it's zonal statistics as table, so you're going to get a table, not a layer. Notice how there's nothing in your layers list, but now you do have a table. And then the zone area, I asked them what they think these numbers mean. I just say, okay, so barren land, 23,857,200. What? And the answer is it is square meters. And the way you know that is what your base map is projected in. It's Web Mercator projection, which is in square meters. And so I tell them that anytime they run a tool that doesn't allow you to specify area units, and this one does not, you're going to get square meters as a result. So we can calculate that. So we're going to go ahead and click the 3 dots to the right of zone area and go to calculate field. And this is the new interface. It's kind of weird, but I talk to them. Do we want arcade or sequel? We want arcade. And then this is a filter. Don't do anything here. You have to go down in the bottom right and click next. It's super weird. All right, so here's your code window. And we just do a crash course in arcade, which is to type a $sign. And then you have these options of data store and feature. We want feature. So I click on feature and then type a period. There's your attribute table. Scroll down to zone area and click zone area. And then divided by, we're going to do acres just because that's what this country uses. You could also do square miles, but I have the number for acres memorized, which is 4047. There are 4,047 square meters in an acre. You can round this if you would like, do anything fancy with arcade, but just basic arcade right here. Go ahead and press run. It works. Run calculation. And then you have to click close now. Okay, so now we know that about 6,000 acres is barren land, and about 16,000 is wetlands, and 19,000 is shrub, 5,000 grasslands, 6,000 woody wetlands. And then this number is going to vary depending on who ran it, and it's not the size of the lake. It is the number of remaining pixels on your screen. So if you're zoomed out like this, it's going to be like 19 million. And if you're zoomed in like this, it's going to be like 4 million or something like that. So now we actually have the values for our different land cover types. So at this point, if you still have time in class, what I would have them do is search for Lake Shasta, which is in California. And it's a little north of where, or it's a little east or west of where it drops you off for some reason. So that is Shasta right there. Do a bookmark. Shasta. And then just to show you, you would go to analysis, your template, open your template. All of this is still the same. We haven't changed the raster. We haven't changed the values. We haven't changed any of this. This would be like Shasta. Just be careful. It will sometimes do coordinates as your processing extent instead of display extent. So you might see this instead. Just make sure you're on display extent. And then, like I said, just run this and it will show up a similar output to Lake Mead for this particular lake. And again, the reason for that is we created a template. We're not running a tool, so everything stays the same. All right, so that is my raster lesson with land cover and also some pitfalls that the students might run into. Please let me know if you have any questions, and I apologize for not being here in person. I hope you have a good time with this lesson.